Okay, in this video we're going to take a look at geom instance and the animation tree. We're going to create some characters out here and do a little crowd animation and see how we can control the crowd based on his animation tree. You can see we've got a character here, a bunch of simple animation. This is really basic, it's just to give something to work with. And what we're going to do is go ahead and we're going to create a rule. We're going to call this crowd because we're going to set it up to be saved as a black box. We're going to create a rule under crowd called born, and here in born we're going to go ahead and use a matter waves to born on this plane. We're going to born just simple 4 particles and set their lifespan to be nice and long and their speed to be 0. And let's go ahead and tell Master Dynamic edit on the fly off and show mesh. This way we get real-time updates and see the mesh. Of course there's no mesh yet. You might think, oh well, let's go ahead and put the geom instance here, but remember that born particle only gets evaluated when the particle is created. Geom instance needs to be able to update this animation tree at every time sample, so he has to be connected to a non-born particle. Let's say what we're going to do for that is we're just going to go ahead and create another rule. This will be called geom instance, and we're going to go ahead and take that all particle group and grab geom instance. And now, because this is just the all particles, this is going to be updated every frame or every time sample. So this is what we want. What we're going to do is we're going to go ahead and tell geom instance we're going to pick this mesh that we've got. Let's see those guys created out there. And we're going to set our offset keying type to be animation tree. This character animation skipped. We're going to go ahead and look at the animation tree section. And what we're going to do here is we're going to define a bunch of different states for the character to be in. States can be single frames or frame ranges. We've got a cheat sheet that we're going to be able to reference here called CharAnim notes. This gives us frames and which pose going to which pose. Right now we're just going to take a look at standing and sitting. We're going to go ahead and create a state for each of those, and then we're going to look at how to transition between the two. Let's go ahead and create a state. You can see it says state 0. All states, this whole animation tree is 0 based, so it starts at 0 and goes up. You can see geom instance, if we expose the A tree state number, what this is going to allow us to do is dynamically pass in a state number, and it will pick which state should be played here. Okay, so state 0, he's got a plus mark next to him. He's got a little subchild now that also says state 0. And we'll take a look at that in just a sec. But what we need to do is we need to give that a long click and call this state standing. And then what we need to do when this top one's selected is we're going to say add range, so it knows what frame range to play to represent that behavior. And the frame range, of course, is just going to be 0 to 0. This is when he's in his standing fully upright. Remember, this is our source character here. These are the particles. So it's going to be standing during the range of 0 to 0. That's fine. Let's go ahead and add the other state. Now you see we've got state 1. So his index is 1. This is we're going to click that and rename that to be the sitting state. And what you can see now is that we have sitting. Sitting has a standing and a sitting child here, and standing also has standing and sitting. What's going to happen is these are transition references, and we'll take a look in a second how to handle those. For now, let's just go ahead and say and define the frame range for sitting that tells him what frames do I play to represent this state. And the frames he's going to play is just going to be 10 to 10. So we'll go ahead and click on this top one, say add range, and punch in 10 and 10 there. Okay, let's go ahead and take a look. What we're going to do is we're actually going to use an integer helper to pipe in a value into the A tree number, and we'll see those particles go ahead and respond, and they're going to go ahead and play whatever state we pipe in on the integer. If it's 0, they're going to be standing. If it's 1, they're going to be sitting. Okay. What we're going to do though is we're going to turn on auto key, have them start sitting, go to standing, stand for a while, go back to sitting, and then stand again. So let's take a look. And what we see is they just pop up pop down, and pop back up. So there's no real transitions between them. Let's take a look at how we can add those transitions. This is where these double greater than or the double arrow sub behaviors come into play. What these do is they say, okay, if I'm in the standing state and I'm going to go to the sitting state, what frame range do I play to handle that transition from this current pose or current state into this next state? And what we do is we click on this transition state here and we say add a range to that. And now we've got a frame range just like we do here. And what this is going to do is it's going to say when I'm in this standing state and I want to go to the sitting state, I'm going to play this range. Well, we know from our cheat sheet that standing to sitting is defined from 0 to 10. So we can go ahead and set this standing to sitting range to be 0 to 10. And then we also know that, let's just go ahead and take a look first. Okay, so sitting pops up to standing, but then when it's going to go from standing to sitting, it's actually going to have a smooth transition. But you can see our sitting to standing does not have a transition defined yet, so it just pops forward. So let's go ahead and handle that. Sitting to standing is 10 to 20, so we'll go ahead and say sitting to standing, add a range on standing, and that range is 10 to 20. So now we get full transitions. We get from sitting to standing, standing to sitting. So this is really just kind of the fast and easy way or description of how to use this animation tree. We're going to define different poses or pose ranges, and then the character is going to be able to have a range that defines that, and then anytime he's going to go from the current state into any other state, there's going to be a range he can look up to figure out how to play that. The thing, of course, is you're going to have all your animations defined in the 1max file. So keep that in mind. Okay, we're going to take a look at how to change this up a little bit. We're going to born quite a few more particles. Let's actually just do 1 per emitter, and let's reduce our emitters a little bit here. Let's go 5 on 5. Let's do 6 and 6. Okay, and what we're going to do is we're going to unhide some of our helper objects in the scene. We've got two helpers. We've got a little animated helper here and a big animated sphere. Let's disable TP and just see what these guys are up to. They go kind of running around in different directions and moving around. What we're going to do is we're going to use this big sphere here to help us control the states of our characters. The way we're going to do that is when the sphere gets close enough to any of these characters, it's going to tell them, I want you to change state. I want you to do something else. We're going to set this up using a memory operator. The memory operator is going to allow each character, each particle, to remember what's my current state, what should I be doing. You could use data channels for this, but memory is very fast and easy, so let's create a memory operator, create an integer, we'll call it a tree state. We're going to go ahead and expose this as an input. So now what's happening here is when the particle's born, he's getting an a tree state assigned to him. We're going to set that to be an integer value. We'll set it to be 1, so we'll have them all sitting when they're born. But we also need to change our geom instance rule and how he is getting his a tree state number value. We don't want to use this animated integer anymore, so we're going to remove that, and instead we're going to go ahead and use the memory operator.